All right, hello everyone, and welcome to today's webinar. Our topic today is Advanced Duct Testing. Jay West, who's usually my support guy, is on vacation today. I do have Jay Evans in the background. We have no picture of Jay today, but can I get a confirmation that you can hear me and see the screen? That would be great to know that we are broadcasting all the things we're after. So thank you for those of you that are out there. So we appreciate that. Let's dig in. I, of course, have too many slides to cover in my time frame, so let me just move my dock to the side there. Great. All right. I've been doing a kind of go on the fly method where we don't really do polls as much as just trying to ask you some questions and get some good feedback. So Cullen Ginge may join us. He's on another webinar that he's probably will jump off and maybe jump on here. And we do have BPI CEUs. If you did not enter your BPI information when you registered, please do so now. I need your name, email address, and BPI member ID. Those are the things that we're looking for you to get that. It is crucial that you pay attention. If this is something that's on in the background, you may not get your attention points and may not be able to get credit. So do make sure this is one of your primary windows that's open on your computer. I can't tell you enough about how Retrotec.com changes regularly, as many websites should, and there's a lot of great information on there. And if you're looking for most of the stuff that we all are after, the support page will give you a lot of the fundamentals, from FAQ page to the webinars to all the articles and other stuff. So we are recording this one, as we record many of our and almost all of our webinars, and we edit them and put them up on YouTube. So this will be recorded. We decided at the end of whether or not this one was better than one of the last ones. So this is similar to some other duct testing ones we do. We do try and make sure they're all up there for people to view, though. So if you're looking for one on any of our topics, including the last one, which was commercial duct testing, all those will be up on the YouTube. If not up there now, up there soon. Common question we get regularly: yes, the DM32 does run the Energy Conservatory equipment. You need to trade in your or buy the gauge, the DM32 Smart Gauge. And you can also trade in your older version to do that. So the quick plug there. Our cloud is out and released. It is up and floating around or running around. So currently it's on Windows tablets and PC. It is not on the Windows Phone. It's a whole other environment to try and program with. Windows 8, Windows 10 on your PC or tablets will get you running. The Windows stores where you can download it. Here's one you definitely want to catch, and that is you can do this through a video, or for many of you, they're going to be at Energy Out West. I do have a couple sessions on duct testing and things similar, but you can also do the Duct Tester Challenge, which is how fast can you do pressurization, depressurization with Energy Conservatory or the Retrotec system and win a $2,500 gift certificate. So those are things that are out there. If you're looking for more information, you can go to retrotec.com, and it's right there on the homepage. You can click on that and get more information about it. All right, first question up. What kind of gauge do you own? You can do both, but if you tell me that, you mean both TEC and Retrotec, or I have the DM2 or DM32. These kind of give me an idea about what the audience is like in terms of what type of gauge they have. I do try to talk universally, but in general, it's all about Retrotec equipment. So the same concepts still apply. So we regularly get a regular group of Energy Conservatory users, so I make sure everybody's on the same page. Okay, let's follow up with the next poll. So next poll I'm looking for is, what type of code compliance do you have in your area? So I'm looking for is like state and county, or state and city, and we are after what type of code compliance. This is not a code webinar, so I'm not going to spend much time on it, but you're after like 3 CFM per square foot, or 4 or 6, whatever that number is that you're actually using for compliance. I know California, they use a different metric, but our goal is just trying to get a snapshot real quick of who's out there, who's doing code compliance. And I guess if you want to give us great feedback, is that, yes, my building official does care if I do the test, because that's one of the challenges out there, is that we have some great codes pushing us as an industry, and we have very little compliance or required compliance from some of the municipalities. So that's some great information if you could chime in with that. So Excellent stuff for those of you that are out there. So I do know what Title 24 was. I was just out in California recently at the KBAC event. So, all right, this is our cue to my quality control measure to know we are recording. So it is being recorded, and we can kick in. So I just want to make sure people know we are talking about residential concepts here. We do have Retrotec does have a commercial duct tester, and we did that on Tuesday, commercial duct testing, and we'll post that on YouTube. But we are focused on residential today. We are going to focus on some basic stuff, which seems basic, but our goal is to talk about them more in advanced ways. So total leakage, leakage to outdoors, and some tests with other tests that include the blower door as part of how to test a duct system. I do have a couple of quick fundamentals that are about how the gauge works, and I do this because a lot of people struggle with what the gauge is doing. They just connect stuff by color coding. The color coding is very beneficial in terms of helping people to be air resistant. All right, but it also I want to make sure people understand what's happening with the gauge and what's going where. So all of the gauges, whether you use either of the Energy Conservatory or the Retrotec gauges, all of the gauges that we use as manufacturers all have two channels built into them. They're basically two manometers in one. So, and what's happening is that they both have an input and a reference. And the channel A is the blue and the red tubes, and that's actually reading the test pressures. And that's usually all day long, is you always just get your test pressure on channel A. Channel B is always going to give me my results and always is calculating what the flows are inside of the fan and give me my results, whether it's CFM or CFM per 100 square feet, or for blower door, it may be air changes per hour. So again, just want to make sure people know what's actually on the gauge and where it's coming from. And that's identical to both of the manufacturers. You do notice that Retrotec does have two tubes that go to their duct tester in their duct tester, and that's so that you can turn the unit around and not have to change any connections when you do pressurization or depressurization. It's just a matter of just flipping the duct tester and reconnecting the flex duct. So it's always monitoring both sides of the unit all the time. And so here's what your system is going to look like from channel A and channel B. You can. I didn't have any handouts to throw in the handout thing. I was kind of distracted this morning with keeping up with a few changes I wanted to put in here. So again, on the support page are all of the quick guides you'll be looking for, and they guide you through visually on how to do the tests we're doing. If you look at the older duct tester quick guides, they include the leakage to outside visuals and setup. So we reduced the quick guide for the current version to try and just make it 2 pages, front, back, front, back. But the older versions have the illustrations to do that. So we're going to go through some basic testing procedures and move through them quickly so people understand, even though you may be doing these things, your why or some of the things that not everybody does. So we know we need to turn off the basic stuff like the exhaust fan, dryers, air conditioners, furnaces, all the stuff that are major movers of the air. But what a lot of people forget is to either open a window, crack a window, or a door, depending on wherever your ducts are located. So clearly, you want to make sure you crack a window wherever the duct tester is, and that's on the inside of the house. But let's say you have sealed attic or sealed crawl spaces, you need to make sure that that hatch is also slightly open or allowing air to move through. You're actually going to alter pressures around these duct systems and in the house when you do the test. The most common one is you may have the air handler or ducts that are in the garage, and if that's the case, you need to crack the overhead door so that you're not actually affecting the pressures around it or restricting the pressures around it, so you have plenty of flow. The most common question I get is, well, I have an old leaky house. You're probably right. The old leaky houses are probably transitioning enough air through that. But to me, I always try and follow a process and know that every time I'm in a house, I'm going to crack a window or make sure that the hatch or the attic hatch, if it's a sealed area, is also available, open to the outside. Okay, so some fundamentals. You're going to seal the supply registers and all of the return grills that you're not actually connecting your duct tester to. Insert the blue tube. I believe that's the green tube for Energy Conservatory to the nearest air handler. You do not need to use a static pressure probe if you're in the supply area. It's just a common best practice. And usually you're going to insert the blue tube in the supply duct that's nearest the air handler. Some people use the farthest from the air handler or will move it around during the test or to make sure. So if you have any concerns that you have don't have pressure or you have dampers that are not opening, that's one way to actually determine if I have pressures throughout the system is to move this tap that I have in my system. So it's a common method to use. If you have an old system that may be clogged for some reason, somebody collapsed something and it's no longer working, then so definitely a method you can use is to move the blue tube. I do want to do a quick slide in here. Some people are doing rough-in tests. Next question for you out there: is anybody doing a rough-in test? And assuming that you're doing this in similar kind of manner where there is no drywall, everything is still exposed, and want to know what's your method for sealing your boots? Because there's obviously many methods, but when you don't have drywall to attach things to, it can be a little more challenging. So in the bottom right, you can use your standard duct mask, but the one I did on the top is actually a chunk of foam that you can actually just put in the boot. And the same kind of foam you have in furniture or similar types of applications. And you could actually I went to Goodwill and waited until they had an old couch that was really on its last leg and was able to buy it. And most of it was all foam, whatever could be recycled was. And so this foam will now live with me for a long time to use for rough-in tests. So it's a cheaper method and finding a better use of it. You can buy this at Amazon or a fabric store. It's not cheap in terms of buying a chunk of foam that's thick enough to do this.
Hey, Joe.
Yes.
On the foam front, I'm assuming they have to use unicellular foam, which means air doesn't flow through it. But there's a real easy test for that. You just suck on it. If you can suck air through it, it means it'll leak. So I would think that the accumulated leaks of all, if it was open cell foam, would be so much as that it would probably, the ducts would show up too leaky, unless you do the trick that I think you might have shown here. No, actually, you're not showing that. You just take the foam and you cover it with a thin piece of saran wrap or plastic and then stuff it in there. So
You can. Most of the furniture foam is a dense foam that is not easily air permeable. Usually, the stuff that's air permeable almost will crush or doesn't actually hold well to being used for this type of purpose or for furniture. So, thanks for that input, Colin. Colin is here. Colin is in the house. So there are a couple duct sealing options that we want to make sure that we're promoting. So on the left is vent cap systems with Corey Breed, and his link is down on the bottom. And Russ King, who's with Duct Block and formerly Sierra Building Science, he has a different method. Corey uses a pole that connects to your opening, and you pull it up with a string, and you can leave it in place and use your pole for the next one. And Russ Kings uses a pole that actually stays in place, and so you need multiple poles for each one of them. So we want to make sure you knew that there were options to avoid using a duct mask when you didn't need to. So there you go. So we're going to go through just some real quick basics so we're all on the same page. That we've sealed off the system. We've installed the blue tube. We've connected and sealed the flange to the main return. It does need to be your return that's nearest the air handler. That usually is the most direct path. I will mention later that if you don't have a direct path, if you only have smaller returns, you're probably going to have to go to the air handler in order to actually make this connection. So I have all of my flange sealed. Everything's connected. I connect the flex duct. And here I do want to make a promo here that Retrotec came out with this around the first of the year, and it still hasn't really hit the press. But this is one of the coolest things on the market today. And to be upfront, it does work on either system. So you can have a duct blaster or duct tester. It's universal in size on how it fits, but this is amazing on how much it'll benefit your methods and how you connect your flange to the grills. So you can see in the bottom left, it's got a little hook that will connect to the grill, and you still have to mask it off like you would any other type of flange, but it stays in place, especially for overhead connections. This is my major challenge that I've had, is that set it up quickly, do the test before it all falls down. I used to use a variety of hooks or whatever, but this is now all integrated with a nice spring. So it's an amazing scenario. So if you're interested in something like that, reach out in the questions area, and I'll make sure that Jay in the background contacts you. All right, so we're going to make our basic connections. We're going to connect the umbilical, which goes from the fan to the gauge, and we're also going to connect the tubing that goes from the fan to the gauge, and basically run a test. So you can pressurize or depressurize, and we're going to go through a couple of the differences. But for the Retrotec system, again, it's just a matter of turning the unit around. So it's a common question is, what else do I need to do or install, or do I need a flow straightener? Retrotec doesn't require any of those elements. So we are really adamant and try and encourage people to do both, even if your municipality, like Washington State or Oregon, I believe, and also California, only require your results to be in pressurization. We encourage you to think about doing both because it can be so simple. When you're doing pressurization, you can see that sometimes your duct mass can actually be blown off the wall or not making connections to the finished surface. And all of these little leakage are leakage that's not inherent to the system at all. It's only leakage that you actually have created by trying to seal the system to test it. So when I depressurize, it will pull all of this duct mass clearly tight to the system. Some other things that I found while talking to people at the trade shows is that they will do both methods because they can then determine that both tests were near each other. Right? They're never exact, but they should be close to each other. They said they have learned that sometimes you have duct leakage that's inherent, that's maybe a slit or a rip in a flex duct, that when I pressurize, it's just part of what they think of as normal leakage. When they depressurize, it actually gets pulled tighter, and some of that leak disappears. So now they know that there's something that's a disconnect between pressurization and depressurization. So in terms of advanced testing, that's definitely an encourage to do both methods because they're really not that difficult with Retrotec to just flip it around and redo the other test. And one of the things that the Duct Tester Challenge is all about is about how to learn the process that's on there. Minneapolis has a couple of as a flow straightener to add an additional tube, and even when I talk to some trainers, they don't understand all the things that are part of that system. So if you are going to depressurize with Energy Conservatory, make sure you understand the additional components you got to put into place. When you are depressurizing, notice that the range and the plugs are inside the flex duct, so you actually cannot see them. You do not move the ring to the other side. It's always on the inlet side where the air is moving into the fan. And so here I'm depressurizing, so that actually would be inside the flex duct, so I wouldn't be able to see what my range was, just to make sure we're on the same page. That's also the same for Energy Conservatory. That's where their ranges go also, is inside the flex duct. So these are the fundamental common questions that we get from tech support is, I can't reach 25, what should I do? And they usually follow a method of starting with range 74. So once you start on range 74, your next step would be to remove 74 and go to either the 102 or the open. The open would probably be my first step because there are some similar overlapping ranges that are there. So if I couldn't reach my test pressure, probably next bet would be to just go to the open range. So for here, I'm only able to get 19 pascals. And you really want to try and get to 25 as best you can, especially if you have not exhausted all other efforts between having the open range and being able to have to use the add pressure. So here I've actually got I'm only at 19 pascals. My fan is maxed out. I'm using 100% speed, even though the gauge may not show that. And everything I can do with the unit opened as much as possible, still only get to 19 pascals or something similar. This is when the add feature will make a difference. So I'm going to activate the add feature, which is in the upper left corner here. And what that does is it will give me the results as though I had actually reached my test pressure of 25 pascals. So it is a backup plan, but again, your first goal is to reach 25. And if you can't, then start removing plugs or ranges until you reach your test pressure. The opposite is when I have reached my test pressure, but I don't have results. Again, that's a common call that support gets is, I have no readings. Why do I not have a reading? And again, you start with range plug 24. And at this point, I don't have enough pressure inside of the fan. That means my ducts are tighter. The proportion of the opening in the duct tester is proportionate to the leakage you have. So the smaller range you got to go to, that's a great sign that you actually have less leakage and you're doing well in terms of how tight your ducts are. So if I change to the smaller range, I want to make sure I change it on the gauge, and then I may find that I actually will get my results that I'm looking for in the gauge. If I still didn't, I'm going to go down another range and make sure I change it in the gauge again. The most common error that people make is that they actually will, of course, change it on the device because they had to do that, and they forget to change it on the gauge itself. I usually try to change it on the gauge first, touch the gauge first, then touch the fan as a habit. And you always, don't always follow those habits, but that's a good habit to try and get into. Touch the gauge and then the fan. All right, so we're going to move through the basic setup here about how everything kind of comes together and move from there. So, I'm looking for questions, see if there's anything we want to address real quick. So we have the system sealed, whether you use grill mask or one of the other methods. We're going to connect to the flange, or we connect to the air handler directly. Then our flange will be connected, and the unit itself. And again, we want to remember that we also need to open or close a window. So our window now suddenly shows up and it gets opened. And connect all of our tubing and the umbilical connections to the fan. And notice that we have set this up to depressurize. So we're going to depressurize the unit, and this is a total leakage test. I'm going to get all of the measurements that are inside the house and leakage is outside the house, all as one test. And if you're going to follow a code compliance, we'll say this home is 2,400 square feet, and 140 CFM divided by 2,400 is around 5.6. In most areas right now, you could be passing. If you are 2009, 2012 or later, you would definitely be failing. So just as a heads up. Depressurize, again, we just send it around, but everything is the same. There's nothing to change or nothing in my setup. Many people may pressurize, some may depressurize, so I'll throw that out as my next question for everybody. How many of you, or do you just say pressurize or depressurize, or I do both? What kind of gives us an idea about what kind of stuff people are doing out there. Most people I talk to are always just kind of been taught to pressurize, when really the better method is to either do both or for sure depressurize. Excellent. Great feedback, everybody. We appreciate your chiming in. So the one thing that is different from just doing diagnostics versus code requirement is that you don't have to do duct testing if the air handler and all of the ducts are in the thermal envelope. I can tell you that that definition changes depending on the municipality, and it's not always common. So make sure if you're following this path is thinking you don't have to test, that you know where that thermal envelope is. The most common one is when the attic has a spray foam and it's considered thermal envelope, but the ducts are in that area. Whether or not you have to test or not is definitely a gray area and depends on where you live. One of the other ones that's out there is the zonal damper challenge, and some people, you don't even know if it's there unless you can find the control panel in one of the mechanical closet, or maybe it's up in the attic. But unless you stumble into this, you really wouldn't know that this is the zone system. Maybe the thermostat may give indications of that, but a lot of times it is not. So I'll go through quickly about how you can determine if your system has zonal dampers. And we're going to assume that maybe they're closed, but I can literally connect my duct tester. I can pressurize or depressurize. The point is I'm going to put pressure into the system and then go around with my gauge just to do a quick check to find out if I'm actually getting pressures or not. And notice my gauge on the bottom right will actually tell me if I really have no pressures, and maybe a small pressure that's kind of leakage. But in general, I should be getting the test pressure I'm after. Again, the whole system is sealed, so when it does open up, and I know it's open, I'm getting pressures inside this individual duct. And I go to the next one and realize that one is still closed. I can go to another one and find out it's open. So your goal is to make sure that they are all open, obviously, when you're doing your test. And some systems are in their natural state open. Some are in their natural state closed. I work with a bunch of folks in California who it doesn't depend on area. It depends on either the mechanical system or how the engineer or the HVAC guy has actually set it up. So it's not a given that they're always open. So if you're not sure or you feel like you're getting funky readings, sometimes one zone can control multiple duct runs, or they can be individual controls over each run. So you want to make sure you're getting pressures throughout your system. Here's an animation I've been using for a while. I really like that it reminds people that duct leakage is a major impact on your envelope and on the house itself, that especially homes that have significant leakage. So we're going to assume that this system runs, let's just say 1,000 CFM, and that each arrow represents half of that. So each arrow is 500 CFM. So if I'm losing half of my CFM in a supply leak, that means my air handler is still looking for 1,000 CFM, and it's going to find it from one place or another. So it's going to grab air from outside and pull that in. So the supply leaks suck on a house. They create a suction, and if you have any kind of a combustion appliance that has any kind of direct connection to the outside, it is the most obvious path that this return path will come in. So if you have, any kind of older homes with a hot water tank in the center of the house, this can be a significant issue. You could have backdrafting caused by your duct leakage. And the opposite is true when you're dealing with return leakage. Clearly, I'm going to be losing or actually gaining extra pressures in the house. So this actually will create a positive pressure. And if you're in a northern climate, this could actually push the moisture that's normal inside the structure towards the outer walls and cause issues. So the best thing you could have is, of course, zero leakage or as close as you can. So there are people who are getting down to, the 10 CFM or less kind of club, and anything less than 50 is a great start. But there are ways to achieve this, or just bring everything into a conditioned area. And I still recommend that it's been sealed. Air should go where it was designed to go. So, okay, so let's start from the beginning on the gauge. So you have your gauge. You want to make sure that you have pascals on the top channel. Again, the DM32 always starts off with wherever you left it off. So if you're doing, 3 duct tests in a day, it keeps the same device you've got. It keeps all the same settings. I don't have to change anything. So if I have the CFM at 100 square feet, which we'll show you in a second, all that stuff stays in the gauge. But when you first turn it on, maybe somebody else had your gauge the previous day. Just make sure you're still in pascals. You're still in the CFM or the reading that you're after for your results. And my device and my range is exactly what I'm going to be using for this test. So to run the test, we're basically going to hit tap pressure, enter 25, and once you hit set, the fan's going to begin to go, and it's going to create the pressure you're after. No matter what you're doing, I encourage people just to use the add feature. It just kind of keeps things stable. The duct testing is usually more stable than the blower door, but in general, your fan can fluctuate from 24, 26 in that range. And when you have the add feature on, you're just going to get the stable reading that you're after. A common question that we get is that I get when I'm usually out in the conferences is that I have a home with 2 units. This was a common thread on even the ICC. Is there is no guidance on this, but there is a general understanding that this is how people apply this rule, and each air handler will be accountable for the air that it supplies or returns from. And sometimes that can be a decision based upon the person testing the house as to where this line actually separates. So sometimes you have foyers or common areas that you can decide as to where this square footage gets allocated to each one of your air handlers. So if I had a 2,400 square foot house and one system was 1,000, the other one was 1,400, then that's how I would divide them and test each one separately, and each one would pass or fail. And if either one of them fails, then you actually have an issue. So here's your basic math that goes along with, again, a compliance. And even if you're not doing code compliance, this is a common method that people compare leakage from one to the other. Sometimes you're just looking for a reduced CFM leakage of a percentage, but usually it's kind of compared to the square footage of the house. So let's say my 107 CFM came directly from my gauge on channel B. And then I have a home that's 2,400 square feet. Now we only have one system in this house. And so the math looks like I get 107 from the gauge, and divide that by the square footage, and you end up with a, you can talk about percentage or leakage per 100 square feet. They're both the same kind of number. Percentage is a lot easier to say. So you can do 4.4, which will become 4.5 times 100. And you end up getting your results. And you can either do the calculation on your phone or calculator, or you can get these results directly in the gauge. So I can see live while my test is running exactly what are my results. I can see them in CFM. A lot of times I need to write that down for code compliance, and I can convert it into my results by entering the area, the square footage of the house, and I can get my compliance directly inside the DM32. I'm going to go through how to change. A common question is, how do I get the result in CFM per 100 square feet? So you're going to tap on channel B. Is the easiest way to get there, and this brings up multiple options in terms of what I want my results to be. So right now I was on CFM, and you can see it's a little brighter red. The next thing I'm going to do is tap on CFM per 100 square feet. And one of the things that people get lost on is they may tap it again, and they end up with different metrics or different units that I have options on, from CFM per square foot to either liters or meters, other metric options. And there's also one that's 1,000 per square feet and 100 CFM per 100 square feet. So once I have the one I want, then I can just tap on the home screen, and it takes me back to the main page. And now I'm actually focused on getting my results at CFM per 100 square feet, but you must enter an area. Remember, we're doing a calculation that's based upon CFM per 100 square feet, and it needs to know what that is. So there's two ways to change the area that you see on the home screen. Is either by tapping on area, or I can, while the test is running, it's showing me what that calculation is based on, and I can just tap this area or the settings, and on the next screen it'll give me the option to change the area, and I can type in whatever I want. Maybe it's 1,500, maybe it's 1,000, and then when I come back I can see that I actually am getting the results based upon 1,000 square feet. All right. Any questions about the what I call the fundamentals, even though there's some good things in there to remind people about? I'm going to do Leakage Outdoors. I'm going to do an illustration that's 3D first, and then kind of go back to some of the setups to make sure we're dealing with the concepts. So I created this in Google SketchUp to kind of give me a guidance as to how to explain it. So here's my house, and I have supply air, and I have return air, and the return ducts are in blue. The rest of them are in their normal gray looking ducts. And if I go to the top, you can kind of see the system that I have here. I have a couple of different supply, and a return that's down below, and a return that's on the back side of the house. And so what I have is I have supply leakage again in red, and I have some return leakage in blue. And the goal is to try and measure the leakage that is actually only in the outside. One of the things that the SketchUp model does is allows me to show stuff that's hard to show in the real world, which is why it's crucial to seal around your boots at the drywall, because you end up with leakage that actually is difficult to see and sometimes even feel around your leakage, because sometimes it goes directly back up to the attic. So here's my system when it's active. I've got leakage inside, and I've also got leakage outside. So this is my challenge that I'm after. I only want to really focus on the leakage to the outside. So we're going to turn everything off and start with 0. We will seal the duct system off as a normal duct test. And I have the options of either pressurizing or depressurizing, as long as the whatever I'm doing for the duct test, I'm also doing with the blower door. They must be doing the same method, which means they're both pressurizing or they're both depressurizing. For visualization purposes, I'm going to start with a pressurization process here. So I have my duct set up, and what I normally would do, I could do a pressurization total leakage test. So this is my total leakage duct test all by itself, so I can do that and find out what my number is. And I want to focus on that leakage there, so now I can add a blower door, And so again, notice that the blower door and the duct test are doing the same concept. All right. So I'm pressurizing and pressurizing on both methods. So as your normal blower door goes, I've already turned it around. If you have an older system, you can use the switch, but it's a better habit to always just turn it around. I'm not concerned about the readings on the blower door. I just need for it to reach a uniform pressure in the house. Okay, so I have my system set up. I'm going to activate the blower door first. It's going to create a pressure throughout the inside of the house. All right, I'll do that again because I think it's pretty cool. So it'll create a pressure inside of the house, and now I can activate the duct tester. And what's happening now is that all the pressure that's inside the envelope, all right, is also now being isolated. So I no longer have leakage to the inside. So that this leakage you can see here, it's right there in the middle on the ducts that are vertical. That's actually now gone. All right, so that was an accident. Whoops. So I'll go back to my next slide. So that's actually the overview of actually what you're doing with leakage outside. So hopefully that gave some people a better idea. And as many people pointed out, there's also the time you would be doing a blower door test. Some people do it before or after, but I would not do my blower door results with the pressurization test. Okay, so we're back to leakage outdoor. So now I created so we make sure it's clear we're using a blower door and a duct tester at the same time to perform these tests. This is also a very basic illustration that I created. So if I have pipes that are leaking, I have, or you can refer to this as ducts, but sometimes the water analogy works well. That if I took this and put a tank down below and had my one pipe going into this area, and I had leaks now inside and I had leaks outside, that if I fill this smaller tank up on the bottom with water eventually, that there'd be no more room for it to leak because it would be full of either the water that's leaking, or I can also think about this as pressurizing this area so it has equal pressure across what my pipes are leaking. So if I have no ability for water to flow out due to equal pressure, the only place that water can now leak would be outside. So it's the same concept with ducts. If I can pressurize or depressurize or create equal pressure inside the envelope, the only place I can have things leak is outside the envelope. So again, fans must be moving the same way. So if I'm pressurizing, I must be pressurizing with the fan. I've turned it around. And again, I'll continue the scenario with the pressurization. A lot of people follow the example when you talk about pressurization. It's easy to visualize it, but it also works the same for depressurization. Sometimes it's a little hard to rack your brain around that things can actually pull on each other equally. Okay, so I got my blower door active. Again, it's going to create a neutral pressure inside. And what I'm after, oops, this should go automatically, is that the duct tester is going to flow, create an equal pressure. And many times you're going to dial this into zero. I'll talk about the two methods, but I'm only going to focus now on actually going to the zero method. So I'll make sure that makes sense to you here. So once I have the blower door on, the duct blower, that's a code phrase, it has equal pressure, then I no longer have leakage to the inside. So my number must be a leakage to outside number. The 2018 review is going to try and bring back leakage to outside in 2018 for a new code cycle, and I thought that was pretty exciting. So the same is true if you're going to depressurize, and that I have the same concept. I'm going to put my fan in, and the blower door will depressurize, the ducts will depressurize, and the area with the blue has all been neutralized by the blower door pressure, and the only I'll measure is leakage to outside. So there are two methods or methodologies or setup processes with this. One of which is to just keep on the left is just use your duct tester as you normally do. You do not change anything. Everything is the same. And you're just going to set to zero. The other one is referencing the exterior, which means I'm going to add a tube and do a similar test, but my duct tester goes to outside. I'm mostly just going to focusing on the set to zero concept. So that's a lot easier to explain, and most people follow this. If you do the reference outside, then you probably are savvy enough to understand that, but I've learned that I confuse more people than not. And I've used this method with the gauge, either controlling it by the knob or controlling it with the gauge, and both work beautifully in terms of trying to do this test and do it well. So one method is once I've reached my interior pressure with the blower door fan, I have that all fan is on, then I can create a set to zero pressure by just turning the knob on the fan. I separate the control cable and use the knob, or I can actually use the add feed or use the set pressure in the gauge itself. Notice that you cannot use an add feature when you're doing the set to zero method, and you must enter zero. A lot of people tell me, well, it didn't work. I went to set pressure and the gauge already reads zero, and then they hit set. You must enter the numeral zero, the number zero, and then press set in order for the gauge to go to zero. Otherwise, you didn't really do anything for the gauge. So the set to zero method is one of the easiest ones to explain and follow. So again, once the blower door is up and running, then it's easy for me to do that. And one of the things I thought that I would go through this. So one of the things that is happening when I do a normal duct test. So this is my normal duct test prior to do my leakage to outside. Is I want to make sure people knew where my reference was. I mentioned earlier that we have to open a window, and when I do a normal test, that I am referencing outside. All right. So this is normal. A normal test is when I actually add the blower door to it. That actually disappears, and I'm now just going to be referencing the inside. Oops, wrong slides. Do it again real quick. Sorry, I had two slides and I forgot to hide one. So I'm referencing outside, and now I'm actually going to be referencing where the blower door is created as a pressure. So you'll see on your gauge, usually you end up seeing a number show up. So once the blower door shows up, I may see a positive or negative, depending on my method, of either somewhere between 5, 7, 10, 12 pascals that I'm then going to move out of the fan and get it back to zero and get my results. One of the coolest things that's out there is virtual gauge and the ability to control both of these from some other place in the house. So I can do it right near that. And again, you're using a PC to use virtual gauge, but I can actually connect both of my gauges either with USB cables or better with Wi-Fi, and I can actually run both of them. So I can take my blower door and say set 25, and I can take the duct tester and hit set to zero, and then I can actually see both my results and confirm that my blower door is at 25 while my duct tester is at zero. That's always one of the challenges. These two gauges are not always able to be seen together. So this is a nice feature to really move into knowing that I am still at 25 when I'm also approaching zero. Okay, that is a heavy-duty topic. Is there any other questions about that? Anything else I should touch on, Colin, that's out there before I move on to the next one?
Hey, Joe, we have one question.
Yeah.
Samantha wants to know if we should perform a blower door test when sealing the duct system to avoid creating any unsafe or unhealthy changes to the home.
I'm trying to follow that again. Let me find Samantha's here. So, Samantha. Can you say it again for me? Should you perform a blower door test when performing duct sealing? I guess the things you want to be careful of is that, before you ever perform a blower door test, you should be asking, does anybody in the house have any respiratory or asthma conditions? Even if you're going to do any kind of even duct testing, you want to make sure if you're going to do any things that could stir up conditions in the house, so you kind of ask those questions ahead of time. So I didn't cover that, but it's kind of a reminder to do that. I don't know if the blower door test prior to doing duct test makes a difference. I may be just challenged in terms of trying to do a live webinar that I cannot answer that. So Colin may be able to help with that. If there's something different, I'll get back with you. So in general, that you're going to be doing the blower door test for leakage to outside. But if I'm just going to do a duct test, one of the things that some people do is they will only pressurize a duct system because they are concerned that if they do depressurization, they may be bringing contaminants into the house. And those are the kind of things that are a experience for somebody who's doing a lot of these or in the house or gets a feeling about what kind of exposure I might be having with how old the system is or how old the ducts are. Taking off a couple of registers will give you an indication about what type of maintenance they've had, if any. Hopefully that helps them. Any other questions we should catch on?
I believe that's it.
Okay, so the blower door subtraction method. How about anybody out there use the blower door subtraction method? It is actually an approved method in Georgia and several other states for code compliance. It is something that some people do in weatherization programs, and is some people feel is very accurate. Some people feel it's way off base. So the method that's behind the blower door subtraction method is that everything is open. I'm no longer sealing off the system to start off. So my ducts are open. I do a normal blower door test, depressurization test, and everything is just wide open. So basically what it's determining is that if there's any kind of leakage, it will be measured throughout the house and through the duct system that's also catching any leaks. And again, this is crucial that you have ducts that are outside your your conditioned or your thermal boundary. So after I've done the first test, then I go to the next test, which is to seal off all of the air handler system returns and supply, and I do my test again. And now, in theory, I should say, well, if I had unsealed and it was 1250 and I sealed it, I had 1025, that my leakage, really to outdoors is what this is measuring, should be 225 CFM. Sometimes that could be fairly accurate. Sometimes it could be pretty far off. That if you're going to use this method, there is a blower door subtraction factor that should be put in there. And it basically is that some people do this at 50 Pascal, some people do it at 25. And there's a way to convert 25 to 50. But also I should be having a gauge that measures the pressure inside the ducts while I'm doing the blower door when things are sealed off. And it's the pressure change that actually will create a calculation to confirm that it's a multiplier to make sure that you have a much more accurate system that you're doing. So if you're going to do the modified blower door subtraction method, you definitely want to use the modifiers. The one that's actually common in a whole different venue of the industry, for those who do home performance, this is their preferred method of doing duct testing, that they don't really like to go in and seal everything off and have those challenges with the homeowner or access. So they actually prefer to do a blower door with a flow hood. And if you're going to depressurize, you really need a powered flow hood or something that is a high-end flow hood that can read these. So the flow finder that Retrotec has is, one of the state-of-the-art, the high-end way of reading things that have airflow into the flow hood. Things that are reading the opposite, like an exhaust fan, which is the exhaust side versus supply side, those all are fairly accurate. They do okay at what they're doing for that job. But if you really want to get down to lower pressures or know that your numbers are dead on, a powered flow hood is the way to go. The difference is a powered flow hood has a fan that's inside of it that allows the fan to actually match the pressures and create a zero pressure area and know that my readings are a much higher level of accuracy. So what most folks are doing, they actually have a passive flow hood, and you can pressurize the house, right? And again, you want to make sure you ask the questions ahead of time before doing these. Evaluate the crawl space and the attic and other conditions to make sure you're not introducing anything to the house. So we pressurize, and the air that's actually moving through the house will actually be measured through the flow hood. So I can now, while I'm pressurizing the house, I can take my flow hood throughout the house and measure each one of the supply and returns and begin to add them up. And again, this is always leakage to outdoor tests that I'm actually doing. This is a compliance method in Kentucky. But again, a lot of home performance folks use it. And one of the things you can do is you get the owners, the occupants are very hands-on. They can see what you're doing. Sometimes people use smoke in tandem with this test, and any smoke that's moving, any numbers on your flow hood shows that you have significant leakage that's outside and they're wasting money. So it's a great way to convince clients that they need to seal their ducts when they see these kind of numbers live while your blower door is going. So I can tell you, based upon these numbers that I got on the return and the supply, that I have 354 CFM of leakage. Definitely some significant leakage in here in terms of getting access to it and sealing. So that's another method you can also use to determine leakage. Nobody out there is using that method, or the subtraction, blower door subtraction method. So not uncommon. There are less of the folks that are out there. How many people use a pressure pan? How about that question? Do we have any people still awake using a pressure pan? So pressure pan is a diagnostics tool only. It does not actually measure duct leakage, but in terms of finding the duct leaks, it is a superior way of determining where the leaks are. And when I know that I have an issue or want to reduce my duct leakage, this is definitely a cheap and simple method that works well. So basically I can use the blower door same as I was using normally. And what we're going to do is we're only focused on channel A for this reading. So channel A is on the top side. So it doesn't matter what I have in channel B or what device I have. I'm using the blue input to the pressure pan, and I can go around the house and basically read different readings. Usually 1 to 2 is normal. 3 is approaching something you definitely need to have corrective action on. Anything above 3 or 4 is definitely showing you have significant leakage in that area. Again, we're dealing with leakage to the outside because anything that's being pulled through with the blower door is coming through and creating pressures around my pressure pan that I can also use for diagnostics. Again, the ducts are not sealed. Everything is open. So the first one was around 1. This one is around 6.8. So I definitely know that I have significant leakage. It's all in this area. And the last one I do is, again, around 1. So I know that my real problems are actually the center duct, and it isn't. It's probably between this duct run and this duct run is the pressures that it's going to grab. So when I go to the attic, I can know that I go to this section immediately and try and find that. Another way of looking at that is if I had 2 back bedrooms and they were split from the same run, that they both were reading the same number, 7.2 or also 7.2. I know that my area of leakage must be where they actually connect. If one of them was reading 1 and one read 7.2, I would know that it was between that common area and the entire run itself. So this actually is a very isolated way of determining or finding where the leaks are. So it's a great method and way to do that. Okay, so there's a couple of methods that are out there to help your ability to access your information. One of which is the Gauge remote. This works on Android and Apple, and it allows me to kind of do, as the name in the phrase, remote. It's kind of like the remote control or the remote reading of the gauge. So if I do want to go around and do leakage on the fly or turn things on or off, this is a great method to do that. You need a gauge that's Wi-Fi to make sure we're on the same page. So my gauge must be Wi-Fi or Wi-Fi enabled, and then I can use a variety of connection methods from either the gauge directly or my phone, or a router that I bring, a little router. So any of those allows me to run through the house and actually see the results live, and can be beneficial if you don't want to stand by the fan or you want to be in the attic and turn things on or off. So that's one of those methods here, which is a duct tester when I'm up in the attic and I don't have a partner that day, but I need to turn things on or off and trying to isolate the leak. Smoke is a challenge with one person, if not impossible, but I can turn it on and leave it on, but I can also seal something, wait for the mastic to set or the tape to set, and turn it on and turn it off, all from being still in the attic and not have to run back downstairs. The other ones out there, as I mentioned, virtual gauge, which can control your device remotely. Again, this actually has a USB option or Wi-Fi. This is awesome for running 2 fans at one time. All right, as we showed that earlier. So there's definitely some options out there. FanTestic is automatic software that many people are familiar with, and they mostly may be familiar with the concept that it runs blower doors or does multi fan testing or multiple option testing. So it also does duct testing. So it actually can do commercial and residential options for duct testing. So that is out there, and you can actually get a version for free for 30 days and upgrade to a light version and use that for duct testing. As I mentioned earlier, rCloud has been released. It is out there in the real world. You can download it for PC. And it does do geolocation, time date stamp, fully automated testing. It'll run your test automatically, save your information to the cloud, and I can share it from the job site to a building official, to a proctor, to somebody who's running your program, your boss, or vice versa. So once it's saved, anybody back at the office can also see these results. So if you're looking for something that is, I feel will be the future of testing, rCloud will be the app that actually will alter our normal path of actually setting up the equipment and then using the total methods of control will be from either your laptop or your tablet, or really probably from your smartphone is what I probably see in about 6 months. Again, I can see everything on a map. I can email it to people. It's really the options that are out there. I do want to make people know, I try to put this at the end so people didn't have to see it in the beginning, so I thought I'd adjust how I normally do things. So you get all the components that you really need to do a system, the 2 ranges, the umbilical, all the parts you need, custom cases, all that is included. And amazing documentation and technical support. You heard Lee's voice chime in there a minute ago. The support team at Retrotec is just highly acclaimed in terms of when people are calling up, they're definitely getting their questions either answered or any kind of strange challenge they have, it gets resolved. And I get a lot of feedback on how impressed people are that when they are confused on the job site, that they're actually contacting technical support and resolving it before they leave the job site. That is the gist of my slides, but I want to make sure we answer anybody's questions, or I can go back and show any of those methods directly. All right, I'm reading over the questions. Anybody else have any other questions? That would be great. Go ahead and throw those in, and we kind of can review what we have here. So Samantha asked, so essentially it's not possible to seal ductwork to the point where it affects the envelope in a negative way. No, that's so that can be correct, but it also can be a challenge. So here's one of the issues that happens, which we did a webinar on static pressure. All right, so and even though it's advanced, there's only so much you can do in an hour. So one of the things you want to be concerned with is that if I overseal a system that was used to having normal leakage, that it thought was normal leakage, and then suddenly I sealed it, I increased its static pressure in the system. So one of the things you want to be or do as a habit is making sure you check the static pressure. And again, we did a webinar on this not that long ago that you can look up. It was about home performance or HVAC techniques and things to evaluate. Because if you have a too high of a static pressure in your system because you sealed it, then you could actually reduce the flow in your system itself. So it is great to seal it well, but you don't want to make sure you didn't increase the static, or you didn't only seal one side. Let's say you only found a huge leak in the return and you sealed that, but you now may have increased the amount of leakage that's on the supply side, which could also create a larger suction on the house. So those are some things you want to be careful about, or make sure you're on cue with. Oh, okay. So there are some good questions here. So, and I may have to. I'm going to do a leakage outside again in June, just to kind of cover some of these. So, what if the duct tester only makes it 20 pascals? Do you take the blower door to 20? And I've been working with a group on some of these challenges that have that. And Colin, do you have the answer out there? Are you out there with us? So whenever I do these, I usually am mentally focused on all the things I had to get through, Bob. So that's a great question. So I'm going to take your question and make sure that I confirm it, and I'll add it to my next webinar. It's one of the ones that I didn't have the last time we did leakage outside, is to what happens when the blower door only gets to 20, or my duct tester only gets to 20, or some of the challenges that go along with what happens with one of them cannot do that. So my understanding is if you're duct, if your blower door only gets to 20, then that's the only pressure you can match. If your duct tester only gets to 20, then you're going to adjust your blower door back down to 20 so that you're dealing with an equal pressure. If you don't have an equal pressure, then one is actually overcompensating the other, is the theory that's behind why you do that. Someone asked if maybe you have a damper issue or maybe you have another issue that's on that. So it's a great question. You guys luckily left them to the end. So best practice when leakage outside with houses that have a toe kick. What he's describing, Anthony's describing the toe kick is like something that's in the kitchen or bathroom that is actually doing a few things. It's using the cabinet as its ductwork, which is not allowed to do either. But it's also allows it because the boot just kind of comes to the floor and is left open to the bottom of the cabinet, and then there's a grill on the front of the cabinet where your toe kick is. So the challenge is how do you get to that? And I don't think there's an easy answer, Anthony. It's one of the things that's very frustrating, especially for older homes, that some may be ducted all the way over underneath the cabinet, but that's actually not that common of an install. It's usually just kind of air is flowing everywhere that's going along with that. So the point is, Anthony saying, well, if I seal the grill at the toe kick, I still have air that's actually moving underneath it. So, I mean, if possible, it would be tried to seal the boot that's underneath it. But again, these are some of the challenges that come along with those types of installs. Yes, a great call by Dick. Someone says that Dick pointed out that increased static pressure, if I have a PSE motor, a variable speed motor is the common term, that my pressure will be fine or still look acceptable, but my watt increase, the amount of electricity that it uses to maintain that new pressure, will have increased. So an ECM motor. So there's two different ways of actually evaluating your static pressure, and that is that, well, did my static pressure go up or stay stable, or did my electric use watt draw also go up on that motor? There is not a frame for the duct tester to be installed in an air handler closet. I'm figuring you're referring to the air handler unit itself, and that is something we don't have. We do have one that goes on a window, but many people just kind of create their own jig or their own template based on the kind of air handlers they're used to, either out of masonite or lightweight plywood or something similar that they consider to be reusable. You can get an extra of the older style red flange, or if you have your red flange, can turn it around and can push your unit inside of that. That flange actually works as a reverse in terms of its connection. Rick asks a question, says, what do you tell your client when your duct test shows 20% leakage? I don't mean this in a sarcastic way, Rick, but you actually have a common system that's similar to all of your neighbors is the reality. Does that mean that that's good? And it doesn't, especially when you have leakage that could be bringing in other issues in your house, depending on where that leakage is. If it's a return leakage and they have a crawl space, that's a dramatic issue, or can be. But the goal is that usually these things can get reduced down to close to 10 or 6. But 20% also means that 20% of their bill is also not being coming to where they live. I usually try to convert the 20% leakage into 20% of their utility bill as the problem. But to me, it's not uncommon to see 20% leakage for homes that are 10 years old, or sometimes even a little less. But anything over 10 years old, it's not uncommon to see 20% leakage. It's kind of a sad state of our construction industry, but that's again just kind of the common numbers that are out there. Anything else? Anybody else? Jay or Lee, you got anything?
I think you covered it.
I don't see anything else.
All right. We appreciate everybody's time. We look forward to seeing you at our next webinars. And if you're looking for another topic, you can shoot that over to support@retrotec.com. And we greatly appreciate any of your feedback or time, and look forward to helping you in another webinar. Thanks again, everybody. Take care.